be different, not the same. Because apply correction. Look at the trees. The trees show you what the small number, the black color 0.09, 0.11, and then the red number 69, 100, 79, 100. Okay, so the tree show you two types of value. The first value is the small values, that's the t distance. The red number, that is bootstrap value, step 5. You will study it. Step 5, the red number. And this one comes from textbook. So show you the color difference between bootstrap and p distance. But actually, when you run mega, generate the tree for you, no different color, only black color. But you have to recognize which one bootstrap, which one p distance. Remember that. Because the same color, black color, not different color. Okay? We will run mega later. You will see the output, the same color, not different color, not red and black color at all. And then based on this one, you calculate the distance for me between two species. You will do assignment. And how to do it? Now, between hawks and dogs. Okay? Hawks and dogs, you identify where the common ancestor. Okay? Hawks and dogs. Hawks and dogs, the common ancestor, the branch from the dog hawks and the branch from the dog go together in the common ancestor with the number 69. Okay? And then how to calculate the distance between two species? You sum on distance from that species to the common ancestor. Okay? So the hawks to the common ancestor, how much? 0.09. The dog to common ancestor, 0.11. Okay, equal 0.2. Simple. Now, you calculate the distance between the hawks and kangaroo, beta globin kangaroo. You look at your laptop, beta globin kangaroo. You have to identify the common ancestor first, which bootstrap number represents common ancestor for species between hawks and beta globin dogs. 79. Okay, 79. And then how to calculate? From the hawks to 79, how many distance? The first one, 0.09, and then no value here, and then from here to 79, 0.19. Okay, that run hawks to 79, beta globin kangaroo. What the values? 0.12 plus 0.18. Okay, and show that. Chứ the key thing doesn't matter where the organism, you have to identify common ancestor first. And then use some own distance from the organism to the common ancestor. Okay? Because you will do assignment and final assignment. Okay? Where final exam I emphasize, and when I review I also emphasize it. But many students couldn't do this then. I think they never go to last how the statement. One student only won 4 points, 14 points. Okay, I will upload video exam this afternoon. Understand how to calculate. Okay? Now, move to model. What is a model? The model applied for nucleotides. The name of the model assumes what all nucleotides occur in equal frequency. Very simple assumption. There are 4 nucleotides, that's right. If assume occur equal frequency, each nucleotide 25%. Not true. Okay, but the assumption when program run the model, that means model give assumption for program to run. Now you understand the difference between model and methods. Methods we will go later, but out of model, that means give assumption. So that's why when you choose different assumptions, the output different. Another one, all nucleotides substituted with equal probability. That means A replaced by C, A replaced by T, or G the same rate. And that's not true. Because nucleotides, so remember, we classify nucleotides the same group, we call purine or pyrimidine. Purine substitute by purine or pyrimidine, substitute by pyrimidine, we got transition. Pyrimidine replaced by purine or vice versa, we call transition. And the rate of transition higher than transition. But here also assume all nucleotides substituted with equal probability. That's the simplest assumption. Okay, so this name. And then the other assumption more complicated. Transition mutation brought by beta actimate of evolutionary version than person. Let me show the difference between transition and transition. But the nucleotides mutation occur also the same frequencies, teaching here. And then we continue with the other model, more complicated. Continue with the other one, more complicated. Just show you different model. That means assumption. Assumption simple or more complicated. More complicated. If assumption more complicated, the tree is more reliable. Because reflect the truth. Happen in the nature. And that is the same for amino acids. We also have different model. Also many assumptions for amino acid. How amino acid changes. That model. We move to construction of phylogenetic tree. That are methods to construct the trees. For the methods to construct the trees, we have two methods: distant base and character base. So what difference between distant base and character base? Distant base, that means calculate the distance between two sequences. Because we input the sequence, so calculate the distance between two sequences, and then based on the distance between, we group sequence into one cluster, and then continue to do it in order to put one organism or one sequence load to the other organism. That's the distance. And the approach, the method here, they will show in one example. Character base. Character base, we have to approach. So we go one by one slide to see it. The distance being traced, calculate the base wide alignment. Base wide alignment. Here we have how many? 1, 2, 3, many sequence, and show you where the difference between sequence we call multiple sequence alignment. You remember you studied that? But actually, when build the trees, the program not compare all sequence at the same time. Program will do what? Calculate base wide alignment. Many base wide alignment. Not compare all sequence together. Many base wide alignment. The other example will show you why many base wide alignment. If two sequences related, put them next to each other on the trace. Because based on many base wide alignment, we'll know which one share more similarity and put them together first and come the process repeat. That we call distance base. Character base. Character base identify position that best describe how characters describe the common ancestor. So that means big methods difference, not calculate the distance, identify the position first. And the position will compare with the other sequence similar to blood shot. You remember, blood shot will identify the seed number in nucleotide different with the protein. Number in nucleotide 11, but protein only 3. Identify the seed for the blood shot and run that compare both directions. Here, similar to that, identify the position, back decline. How to understand back decline? The other slide is planet. So here, identify the position with character. Example with distance, make that methods first. One example, UBG Upchima, the name, the full name. On sequence compare two base wide alignment. You see, on sequence, it doesn't mean on sequence compare together. On sequence compare two base wide alignment to compute the distance matrix. Okay. Sequence 1, 2, 3, 4. Okay. Now base wide alignment for on sequence. So that's why 1 compare with 2. 1 compare with 3, 1 compare with 4, 2 compare with 3, 2 compare with 4, 3 with 4. Okay? And then, for example, look at 1 and 2. How many position different? 2. Divide 10, because the length of the sequence 10. So that's why 0.2. And continue for the other base wide alignment, the value here. And build the matrix. And look at the matrix here. The smallest values doesn't show loads relationship between them. So that's why based on this one, we will put 1 with 4, 2 with 3. Okay? That example how to calculate the distance and continue. For example, we have the matrix after finish this one here. Finish it and then continue. When we finish, we have PD. only one, so that's why it go together. And then we still have A and C. Have to put A and C, which one next to BD. So that's why we have to calculate continue the distance between A with BD and C with BD. This box show you how to calculate the distance, the value from the matrix. Okay, number 3, AB 3, AD 7. Okay, average, so that's why 5. And then C 3. So you have a new matrix. In the new matrix here, C smaller value 3 compared with 5, so that's why B, D, C go together and remaining 5. And remaining 5 calculate the distance how much. So that's why at the end had the trees with the distance, Okay, just explain for you understand program, how program process the data. When you put the sequence to program, actually you don't do anything. Because the program do for you. I just explain how program do it. For you understand. Step by step. Now, 1 low switch 2 group together. 4 with 5 group together. How about number 3? Number 3 low 2, 4, 5. So that's 1 low. Just step by step. That's done. One example how to calculate the distance. And then the neighbor joins. Neighbor joins similar to that, but start with star. And calculate also phase Y alignment. And calculate phase Y alignment. Identify 1 and 2 and smallest value, put them together and continue with the other one. So at the end, have the trees. And the tree produce single trees have minimum total branch length. Remember, minimum total branch length. That's the principle that the programmer build the trees. Because can generate many trees, not single trees. But the program based on how to score the distance. Calculate the distance. And then identify, generate only one tree for you. The output only one tree, not many. And the output here the minimum total branch length. I will show you where you can check the total branch length because the assignment asks you do that. You get the answer, the branch length. They were joining methods, the one wide use distance matrix methods may get is this one. We will write it. Now, character-based methods. One method we call maximum parsimonies. Also select the sorted trees. That means the branch length also minimum. Okay, that's the maximum parsimony. How to do it? Maximum parsimony method. Compute many trees run given data set assign a code to each trees. Also assign the code, the score to each trees. The symmetries, the one require fewer number of genes to explain the data. The tree score the sum of character length, also the sum of character length. For this trace, the program will do what? The sign or position of the student that at least 2 different time reference. Take in at least 2 of the sequence considered to be an informative site. So that means for this methods, program identify where informative site. Look at here the example. We have sequence 1, 2, 3, 4. And the length 1 to 9. So 9 neural time.